Hello everyone and welcome back to Diksha Karnataka YouTube channel, and today I am going to bring you the most important questions from all the chapters of your second PU midterm exam, and this is only for those who are struggling to get the passing marks. So if you follow this video, you will be very close to getting your passing marks. This is not a high scoring video where you will score all the high scoring marks. To score high scoring videos, to get high scoring in your say midterm video, you have to check all the videos that we have done in our physics section. So there are already 5 videos already uploaded. So this will be the last video for students who are a little bit struggling to get the passing mark. Also, this is with a fair warning. This is only for getting the passing marks, and you have to go through all the questions. You cannot do suggestion on this. This is already suggested. This is already shortened version of all the questions. So don't do any more suggestion on that. Then your passing guarantee is not mine. Otherwise, if you follow all the questions, you will be able to answer some questions, and so that you can score the minimum required marks to pass your theory exam, that is 21 marks. Okay, now let's see. It is most expected question. In some cases maybe you will get all the questions common and you will score 80 marks. Maybe in some cases you will only get the minimum questions and you will score 21 marks. Otherwise it is just a question paper. Okay, so what all we are going to do here, we will have total 15 MCQ questions and total 5 fill in the blanks question. Then we will also have 5 short answer type, 5 short answer type 2 marks, 5 short answer type 3 marks, then 5 long answer questions, and only 2 numerical questions, because this is focused only for weaker section of the class. So I am not going to discuss all the long answer, all the numerical questions. So let's start with the MCQ questions. The total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by the surface. This is the statement of. So what is this statement? This is the statement of Gauss's law of electrostatics. So if you have to know, this is the statement of Gauss's law of electrostatics. Next is the electric potential due to a negative point charge at a distance r. So electric potential due to a negative charge is given by minus kq by r. This negative sign comes from because the fact that q is negative. So if you include the q negative, then it will be negative. So we can say that it is a negative and varies with 1 by r. Is electric potential, not electric field. Electric field varies with 1 by r square. Electric potential varies at 1 by r, and because the charge is negative, the potential will also be negative. Now let's start. Let's move on to the next question. The following are the statements and related statements related to self-inductance. Okay, the self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. It's a correct statement. This statement is correct. Okay, obviously self-inductance depends on the geometry. It also depends on the mu naught, that is mu naught or mu, if you are saying, because if this is vacuum, then it will be mu naught. If it is not vacuum, then it will be permeability of the medium, right? Now, what is the statement 2? Self-inductance is measure of electrical inertia and opposes the change in the current in the coil. Yes, self-inductance is the measure of inertia. Okay, so basically both the statements are correct. So both statements are correct is the correct answers. That is option number C. Now, let's move on. Next question. A ray of light is incident on glass air interface at an angle greater than the critical angle of the pair of the media. Then the ray undergoes. So when the angle is more than critical angle, the ray undergoes total internal reflection. You have to remember that, right? If the incident angle is equal to critical angle, then it grazes, the last option, grazes the surface at the interface of the two media. But here the angle is more than critical angle, so it will suffer total internal reflection. Okay, now Now there is a statement based question. Again, statement 1, the resistivity of metals increases with increase in temperature. Yes, resistivity increases with increase in temperature. Increasing the temperature of metals causes more frequent collision of electrons. Yes, as the temperature increases, the electrons start colliding more, and thus it increases the resistivity. So this is the cause, this is the statement, this is the reason. Okay, so both 1 and 2 are true, and 2 is the correct explanation of 1. Yes, this is correct explanation, this is correct reason. Okay, assertion, reason, whatever they can give you, assertion, reason. Okay, assertion is correct, reason is also correct, both are correct. Statement 1 is correct, statement 2 is also correct, and it is the correct explanation, right? So this is the answer. Now next question. The Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic field, only crossed electric and magnetic field. Okay, Lorentz force is applicable for both electric and magnetic field. It does not depend on whether the electric field are crossed or not. If it is an electromagnetic wave, in that case maybe you can say, okay, electric and magnetic field has to be perpendicular to each other. Crossed means perpendicular to each other. Okay, but that is not, it is applicable to both electric and magnetic field. Now next question, the direction of current induced in the loop ABC shown in the figure is along ABC if increasing, along ACB if I is decreasing, along ABC if I is decreasing, along ACB I is constant. Now out of this, constant one is obviously incorrect, because if there is a constant there will be no induced magnetic field. Okay, so induced magnetic field depends only on changing magnetic flux linked with the coil, and magnetic flux will change only if the current changes, right? This is one of the way. Now let us see how the magnetic field is changing. Now in this case current is flowing in this direction, so you have to put your fingers like this in thumb along the direction of current, then your fingers will point the magnetic field which is into the paper. Into the paper is denoted by a cross, right? We know that. Now if the magnetic field is into the paper, then how it will change? If magnetic field, if the current decreases, if the current decreases, then the associated magnetic field will also decrease. If associated magnetic field also decrease, then this loop will try to increase the magnetic field. Okay, so in that case, if current decreases, then it will be in the direction of ABC. Okay, so if the current decreases, then it will be in the direction of ABC, because it will try to increase the magnetic field. Okay, so as we know, for a circular coil, now your fingers will be in the direction of along the current, and your thumb will point towards the magnetic field. Okay, so because I is decreasing, then only it will be along the direction of ABC. So correct answer is option C. Okay, along ABC if I is decreasing. Other two options are incorrect. You can check them individually. Now let's move on to the next question. The average power dissipated in an AC circuit is maximum if the AC source is connected to a pure resistor. Okay, so only when a pure resistor is connected, then power dissipated is maximum. Okay, you have to remember this option. Next question, the displacement current is due to, now this is a new question, displacement current is due to flow of electron, flow of proton, changing electric field, changing magnetic field. So if you remember, displacement current is where you have two capacitors and it is connected to a battery, and we said that there is a current flowing in this, but there is a gap between the plates, so there was no current, but actually there is a current. This is called displacement current. Okay, and this displacement current is equal to the conduction current, and this displacement current occurs because there is a changing electric field between the plates. Okay, so because of the changing electric field there is a displacement current, so correct answer is option C. Now statement 1, again another statement based question. Statement based questions are very popular nowadays. Okay, and one or two such questions are expected. The net magnetic flux through any closed surface is 0. Okay, so net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by the number of lines entering it. So we know that north south pole magnetic field lines are closed, So number of field lines that is exiting, the same number of lines are entering. So that's why we can say that obviously it's a correct statement, both statements are correct, and 2 is the correct explanation, obviously, because there is no magnetic monopole exist. Okay, because there is no magnetic monopole, so number of field lines exiting, there should be equal number of lines entering the surface, right? So total number of net flux will be 0, net flux 0 will be, that is the thing, right? Now the electromagnetic waves with lowest frequency among the following. So which of the following has the lowest frequency in the electromagnetic waves, right? Let's see. Gamma waves, UV rays, microwaves, radio waves. So lowest frequency means which has the highest wavelength. Either you can remember in terms of wavelength or you can remember in terms of frequency. So in terms of frequency, gamma rays has very high frequency. Okay, UV rays are after that. Microwaves are much below UV rays, but it is more than radio waves. Radio waves has the lowest frequency. Okay, lowest frequency but highest wavelength. Okay, it has highest possible wavelength among these all 4 options, and because it's a high wavelength, it is also has a lowest frequency. Okay, frequency and wavelength are enemy. They don't like each other. If one is high, another one will be low. Okay, so this is the thing. Now question number 12. Current density is a vector. Obviously current density is a vector. If you remember, J is given by current density and it is sigma E, right? If you remember, this is the alternative version of Ohm's law. Okay, so current density is a vector quantity. Also we know that scalar form is I by A. Okay, so its unit is ampere meter to the power minus 2. Okay, current density is current through unit surface area, right? So it's a vector and its unit is ampere per meter square. So correct answer is option C. Okay, don't get confused. Okay, many student mentioned ampere per meter cube when it was given in the exam, so it will be ampere per meter square. Okay, now let's move on. Question number 13. A straight conductor of length L is moving with a velocity v in the direction of uniform magnetic field of strength B. The magnitude of EMF induced between the ends of the conductor is. So very careful, okay, to answer this question. This is a tricky question. Okay, most students will closely answer BVL or BLV. Here you have to remember that here the direction is based on the direction of B and V. Okay, here they are saying that they are in the same direction. Okay, moving with the velocity v in the direction of uniform magnetic field. So in the direction of magnetic field means we know that this is V cross B. Okay, V cross B means, okay, times L. Okay, so there will be BVL sine theta. Okay, if they are in the same direction, then theta will be 0. If theta is 0, then this value will be 0. Okay, so 0 is the correct answer. If they are perpendicular to each other, if the same question is asked with the magnetic field is perpendicular to the velocity, in that case it will be BVL or BLV. Okay, but since they are in the same direction, it will be 0. Okay, so be careful about such questions. Now, an object of finite height is placed in front of a concave mirror within the focus. Okay, so concave mirror is there. Okay, an object is placed within the focus. So this is the focal length. If you place an object within the focus for a concave mirror, as we discussed, it will be forming a virtual image, right? It will form a virtual image and it will be enlarged. Okay, that is the property of concave mirror. When the distance is less than focal length, it will be forming a virtual and enlarged image. So correct answer is option C. Right, now question number 15. The ferromagnetic material among the following is. So now this is a little bit tricky question. Copper is a good conductor, but it is not a ferromagnetic material. Okay, only nickel is a ferromagnetic material. Nickel, cobalt and iron, these are the most commonly used normal ferromagnetic material. There are some alloys, but nickel, aluminium and cobalt are nickel, cobalt and iron are the 3 most commonly used metals that has they are ferromagnetic. Okay, so nickel is a ferromagnetic material, copper, lead, calcium are not ferromagnetic. Okay, now let's move on to the fill in the blanks part. Here also we have 5 questions. One of the basic properties of electric charge is, so let's see the options: decrease, increase, no, quantization, yes. So quantization is a property of charge, so we can write quantization. Okay, now as the distance between the plates of capacitor is increased, the capacitance, as you increase the distance between the capacitor plate, we know that capacitance is given by Ka epsilon naught by D. So if you increase the distance, then capacitance will decrease because it's inversely proportional, so it will decrease. So correct answer is decrease. Okay, read the question, fill in the blanks. After filling the blanks, read the statement if it is making any sense or not. For example, here decrease, increase both make sense, but only decrease is correct answer. But if you write property of charge is decrease, that does not make any sense, that does not make any grammatical sense, right? So grammatical sense also has to be there, right? So there are some distractors will be there where you might get confused, but otherwise if it is not at all making any sense, then you can directly reject it. Okay, the device which works on the principle of electromagnetic induction is, the device that works on the principle of electromagnetic induction is AC generator. So AC generator. Okay, okay. Now a rotating vector used to represent alternating quantities. Alternating quantities, any rotating vector, that is a phasor. Okay, next, the magnetic susceptibility is negative for dash materials. What type of material has negative magnetic susceptibility? Only diamagnetic substance. Okay, paramagnet and ferromagnet, they have positive susceptibility, but paramagnets has very small value, whereas ferromagnetic has a very high value. Okay, so in terms of value, magnitude of values, there are different answers, but diamagnetic are the only one having negative magnetic susceptibility. Okay, now let's look into 2 marks question. Write Coulomb's law in vector form, explain the terms. So first of all, what you have to do, you have to show 2 charges, Q1, Q2, separated by a distance r. Okay, then you have to take a unit vector r cap, then you can write this, or the diagram that is given in your book, you can draw that also. Okay, so here the force is given by F equals to 1 by 4 pi epsilon naught Q1 Q2 by r square r cap. The statement is given here as well. Okay, in case they ask you write state the Coulomb's law and write the formula, so that is the statement and this is the formula. Okay, and this is the explanation. In terms of explanation, you have to draw the diagram and mention all the variables. Okay, now on what factors does the capacitance, this by the way, this thing will be available as a form of note in the end of the video description. Also it will be shared on our WhatsApp group, so if you have not joined our WhatsApp group, please join our WhatsApp group. The link is given in the description, so you can download the lecture note from there also. On what factor does the capacitance of a parallel plate capacitor depends? There are few factors. We have seen the equation, capacitance is equal to dielectric constant K, permittivity of free space, then area A divided by D. This is the formula for capacitance of a parallel plate capacitor. So if you write this equation, very good. Okay, otherwise you have to remember these points. If you remember this equation, then you can write, okay, C is proportional to A, that is capacitance is directly proportional to the area of the plates. Okay, area of the plates. Okay, now second number is C is inversely proportional to D, so inversely proportional to the distance between the plates. Okay, third point is directly proportional to the dielectric constant kept between the medium. Okay, kept between the plates. okay, dielectric constant of the medium kept between the plates. Okay, so this is the correct answer. Now this is optional, obviously. 2 points, they ask you 2 points, you can write 2 points, but if the same question is asked as a 3 marks question, then you have to write 3 points. That's why these questions are interchangeable. Sometimes 2 marks questions are asked as 3 marks question, sometimes 3 marks questions are asked as 2 marks question. So you have to be ready for that. Now, when does current carrying conductor placed in a uniform magnetic field experience maximum force? When do they experience maximum force? When the current is flowing perpendicular to the direction of magnetic field. So when the current and the magnetic field, they are perpendicular to each other, then the force is maximum. Okay, minimum force when the current and the magnetic field are in the parallel, then it experiences the minimum force. Okay, that is zero force. Minimum force means zero force, right? State Faraday's law and Lenz's law of electromagnetic induction. Okay, so what is Faraday's law? The time rate of change of magnetic flux through a circuit induces EMF in it. Okay, so this is Faraday's law. So basically, epsilon induced EMF is directly proportional to rate of change of magnetic flux. Okay, and Lenz's law states that the polarity of induced EMF is such that it tends to produce a current which opposes the change in the flux that produces it. So from Lenz's law we can write that opposite means a negative sign. So if magnetic flux is decreasing, then it will try to increase. If the magnetic flux is increasing, it will try to decrease it. Okay, that is the property. Okay, now mention 2 limitations of Ohm's law. This is also 3 marks, can be a 2 marks question. So Ohm's law is applicable only if all the physical conditions remain same. So physical condition means state of the material, length of the material, etc. So if they are remain same, then only Ohm's law is applicable. Ohm's law is not applicable to very low and at very high temperature. So if you remember the statement of Ohm's law, it says that when the physical condition and temperature remains constant, so in that case very high temperature, very low temperature, Ohm's law is not valid. Next, Ohm's law is not applicable to non-ohmic devices like semiconductors, okay, discharge tube, etc., superconductor also. So that is not applicable to non-ohmic conductors. Okay, now let's look into the 3 mark questions now. Okay, write any 3 properties of electric charges. I will suggest one more thing that you remember, though even though this is a different question. Okay, 3 properties of electric field lines. That is also very important and common question asked by the teachers. Field lines. Okay, now what are the points? Additivity of the charges. Charges are additive in nature, that means you can add them. Okay, just like a scalar. Quantization of charges, all charges are integral multiple of smallest charge E. Okay, conservation of charges, total charge in an isolated system are conserved. Okay, so if they ask you 3 properties of charges, don't just mention additivity of charge, quantization of charge, then conservation of charge. This is not makes any sense. Okay, and the teachers might deduct some marks if you explain it in at least 1 sentence, because it's a 3 marks question, very easily scoring part. So write 1 sentence at least for these questions. Now derive the relationship between electric field and electric potential due to a point charge. Okay, so first of all you have to draw this diagram. Okay, in this diagram, in your book the diagram is wrong. Here it will be V minus delta V. Okay, and electric field is pointing from higher potential to lower potential. That is the direction of electric field. Now suppose we take a point charge Q. Suppose let us take a point charge Q and point test charge Q and try to move it from A to point P. We are moving this point charge Q from A to P. Okay, and this is an equipotential surface. Electric field is almost constant along this direction, almost constant. So suppose the electric field here is E. Okay, if electric field is E, then what is the force acting on this charge? Force acting on this charge is given by Q times E. Okay, so this is one equipotential surface, this is another equipotential surface, and the distance between them is delta L. Okay, or DL. Okay, you can use this as DL and DV. I will, even though in the diagram it is delta V is written, I will use DV and DL. Okay, now this is the force. Okay, now work done can be calculated in 2 ways. So work done can be calculated in two ways. What are those? First of all, our old mechanical process, that is force work done dW is given by force times the displacement. Force times the displacement is the work done. So, that is QE, force is QE times dl. This is our old method. And what is the new method? New method is from the definition of electric potential. What is that? Electric potential, from the definition of electric potential, it says that final potential is V minus dV and minus initial potential, that is change in potential times Q. Change in potential times Q is the work done. Now, if you see, there you will get minus dV Q. Okay, because it is moving from higher potential to lower potential. That means external system is not doing any work. You are only, the charge itself is doing the work. Now, if you have to compare these two values, so comparing 1 and 2, we write QE dl equals to minus dV Q. Now, Q cancels. So, E equals to minus dV by dl. Okay. This is the relationship between electric field and electric potential. Okay. This is the relationship between electric field and electric potential. The negative sign is important. Okay. Also, it has to be in the one direction. Okay. Now, let us move on. State and explain Biot-Savart's law with a suitable diagram. So, suitable diagram, I hope you already know this is a very common question. You take a diagram like this, you take a small portion here, okay, and then you take a point P here, some point, any point P, okay. You say the distance is R, this is dl vector, okay, and the angle between this and R is theta, okay. Current I is flowing in the circuit. Then, according to Biot-Savart's law, the magnetic field produced here, say dB, okay, and the magnetic field produced here dB is directly proportional to the length of the element dl. Okay, we are not using vector form here. And then number 1, number 2, dB is directly proportional to the current flowing in the circuit. Number 3, dB is inversely proportional to the square of the distance. And number 4, dB is proportional to the current, sine of the angle theta. Okay. In combine them everything, we can write dB is equal to I dl sine theta by r square, and there is a mu naught by 4 pi. Okay, mu naught by 4 pi will be there, as I said in all my lectures. Okay, so it will be dB equals to mu naught by 4 pi I dl sine theta by r square. Okay, so this will be the formula that you have to write at the end. Now, let us move on to the next question. Derive the expression for motional EMF induced in the straight conductor moving perpendicular to the uniform magnetic field. This is also a very important question. So, first we have to start with the definition of magnetic flask. Magnetic flask is defined by magnetic field times area. Briefly describe this diagram as well. The diagram is compulsory here. Now, what is magnetic field B? Magnetic field B is given, and what is area? Area is, this is a rectangle, right? This is a rectangle. So, rectangle means area will be length into breadth. Length is L, breadth is X. So, area will be L times X. Okay. So, this is the magnetic flask. Now, what you have to do? You have to find the induced EMF. Induced EMF is minus B L, sorry, let me not write it here now. What we have to write the formula first, minus d phi by dt. Okay, this is the rate of change of magnetic flux with time, that is the induced EMF. So from this expression we can write B is constant minus BL, then we can write dx by dt. Okay, now what is dx by dt? Dx by dt, in the mechanics chapter we learned that dx by dt is nothing but speed, right? Now here dx is going in this direction, so we generally consider this is our positive x-axis, right? Positive x-axis, here x is decreasing. X is decreasing means it will be negative of the velocity, sign of the velocity will be negative. So what we will do, we will put that negative value here, minus BLV, okay, and this minus minus will become positive, so it will be BLV. Now remember that in the MCQ question, the question was when magnetic field and the motion is in the same direction. Here you can see that magnetic field is into the paper. Okay, cross means into the paper. Basically this is a target that to which you can throw the dart. So that's why the cross represents the dart throwing practice. So that's why it is cross. Okay, dot means out of the paper. Okay, so here as you see the magnetic field is into the paper and velocity is in this direction. So they are in the mutually perpendicular direction. If this is there in the mutually perpendicular direction, there is no angle coming over here. But if the same problem they ask you, the magnetic field and the motion is in the same direction, then it will be 0. Okay, be careful about that. Now write 3 differences between diamagnetic and ferromagnetic material. Okay, so what are the difference between diamagnetic material? You have to write the table. This will be question number 5, I think. Okay, there are multiple differences. I will just give you a few points, that is susceptibility is less than 0, negative. Okay, susceptibility is negative and small susceptibility is positive and large. Okay, it slightly repel magnetic field lines, and it highly attract magnetic field lines. MFL is magnetic field lines. Okay, so in case you are wondering. Okay, next you can write they cannot be converted into magnets, cannot be converted into magnets. This point is not valid for paramagnetic. Paramagnetic can be converted into magnet below certain temperature, but diamagnetic can never be converted into magnet. Ferromagnetic can be converted into magnet. Converted into good magnets. There are many other differences. You can check the difference table given in your book. Okay, these are the very basic 3 points that I gave you. Okay, now let's move on. Okay, this is question number, I think I gave you one extra question. Anyway, let's see. Obtain the expression for the effective capacitance of 2 capacitors connected in parallel. So connected 2 capacitors connected in parallel, very simple question. 2 capacitors, I will just do it quickly without wasting any time. 2 capacitors, this is C1, this is C2, and the equivalent circuit can be drawn using only one capacitor and the battery. Okay, this is C equivalent. Okay, we are trying to find this C equivalent. What is the equivalent means? Equivalent means if we replace these 2 capacitors and place one capacitor doing the same thing. Okay, if these 2 capacitors are, suppose they are doing something, and if I replace them with one capacitor doing the same thing, that is called equivalent capacitance. Okay, and in reality we are doing the opposite of this. Okay, so we know the equivalent capacitance, and from there we find how many capacitance we can connect, so that they are actually giving me the equivalent capacitance. Okay, so while studying the theory, we go from here to here, but while doing the practicals, we start here, then we reach here. Okay, that is the difference. But if you know the formula only, then you can apply, right? So that is why it is important. Now, what is the suppose the charge stored here is Q1, charge stored here is Q2. Okay, so from capacitance we know that Q equals to CV, so Q1 equals to C1V. Potential across both the capacitors are same here. Okay, they are connected in parallel. In parallel, potential is same. That is the parallel combination. And Q2 equals to C2V. Right. Now, what is the total charge? Total charge Q is Q1 plus Q2. That is the total charge flowing through the circuit. Now, when you are trying to find the equivalent capacitance, the total charge will remain unchanged. So, the charge through the equivalent capacitor will be same, that is Q. So, we can write, instead of Q, we can write C equivalent times potential V. Now, again it has the same potential. So, CV equals to, now instead of Q1 let me write C1V, and instead of Q2 let me write C2V. Okay, so this is this, this is this, this is this, right? So now V is common, it will cancel, so we can write C equivalent equals to C1 plus C2. Okay, this is the equivalent capacitance of the capacitor. Now, for derivations, I will give you the derivations formula and some tips. You can study the derivation at your home. These are long derivations, so I am not going to take you all the through all the notes. If you want any specific derivations, you can ask me. I will provide you the note links. But for now, you can find this derivation in your guidebook, in your notebook, or in your textbook as well, NCERT, that is. Okay, so but you have to prepare them. They are important derivations for your midterm as well as your final exam also. Okay, these are not only important for your midterm, they are also important for final exam. State Gauss's law. Statement of Gauss's law is given in the first MCQ. Okay, so the charge enclosed divided by 1 by epsilon naught, or 1 by epsilon naught times charge enclosed in a closed surface is the Gauss's law. And here they have asked you to find a long straight current carrying charged wire. So in case of charged wire, what you have to do, you have to know that the charge per unit length, that is lambda, and then you have to assume some length, some arbitrary length L, and then total charge enclosed by the cylinder will be, lambda times L. Okay, lambda is charge for unit length, so for L length it will be lambda times L. Okay, now you have to use the Gauss's law, E dot ds closed surface integral E dot ds is equal to Q enclosed by epsilon naught. Okay, E is spherically constant, so everything is given in your book that you have to write. ds is 2 pi r L here. Okay, r is the distance where you are measuring the magnetic electric field, right? That is the radius of the cylinder. Okay, 2 pi r L equals to Q enclosed is lambda L divided by epsilon naught. Now L will be cancelled, so you can get electric field will be lambda divided by 2 pi r epsilon naught. This is an easy derivation, but this is not sufficient. Okay, this is just the basic structure. You have to do the description. You have to mention what is E, what is Q enclosed, what is lambda, what is L. If you do not describe the terms, they will deduct marks, and if you do not draw the diagram, they will deduct marks definitely. Okay, now define electrostatic potential due to a point charge and arrive at the expression for the electric potential at a point due to point source at the charge. So what is the electrostatic potential? The work done to bring a charge from infinity to any point at electrostatic potential, right? So bring a unit positive test charge to bring a unit positive test charge from infinity to a point in the electric field is the electric potential at that point. Okay, so the work done to bring an unit positive test charge from infinity to a point in the electric field is the potential, electric potential, at that point, right? So I hope you will remember this, and then you have to draw that diagram. This is one of the very easy derivations and very commonly asked derivation. Okay, you have a charge here, some charge here, and you are bringing suppose you have a charge, say capital Q, and you are bringing a positive charge, test charge small q, from infinity to a point. Then you have to take some in between arbitrary position, and then you have to form an integration, then integrate it. Okay, so to find the potential, that will be, final result will be V is equal to KQ by R. Okay, KQ by R. Okay, you can take this charge unit positive 1 as well, no problem. Okay, as long as your mathematics is correct, you will get the full marks. Now, derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. Now, this is a tricky question because students don't know how much to write, so that's why I am giving you the written solution. First of all, you have to draw these two diagrams. Okay, at least this diagram is compulsory, this diagram is optional, but if you draw it, it's very good. This diagram is compulsory, and but you have to mention that at the angle of minimum deviation, okay, you have to write this equation that minimum angle of deviation is given by 2i equals to delta m equals to 2i minus a. From here I equals to a by delta m by 2, and then you can write also for minimum angle of deviation, okay, a is equals to 2r. Now, the refractive index of the prism is given by, what is the formula for refractive index? Formula for refractive index is sin I by sin r. Then you can put the values of I from this equation, values of r from this equation, then you will get the also here you can write one more line here, that is r equals to a by 2. Okay, so substituting you will get this answer. This is the final expression. You have to explain these terms a little bit. Okay, that's it. Okay, no, mathematically only this is the important part, but you have to add some explanation to get the full marks out of this question. Okay, now arrive the balance condition of the Wheatstone bridge using Kirchhoff's law. First of all, you have to draw this diagram, then you have to apply KVL here. Okay, KVL here as well. The derivation I have done in my regular lecture of the chapter current electricity, you can check there. Okay, and the condition for balancing will be R2 by R1 or R1 by R2. Okay, R1 by R2 equals to R3 by R4. So, if you are doing this here from here to here, here divided by here equals to here divided by here. Okay, or this divided by this equals to this divided by this. So, what you can remember is this divided by this is equals to this divided by this. This is also fine. Okay, that's how I used to remember when I was a student. It was a little bit complicated for me at that point of time because I have not done any practice and I appeared for my midterm without any practice. So that's why I had to remember it like this. If you are like me at that point of time, then you have to practice a little bit more. Okay, just joking. Now, next question, derive an expression for the magnetic field at the point on the axis of a circular current carrying loop. So there is a loop here, and you are trying to find the magnetic field on the axis of the loop. So here you take the current carrying loop like this, then you take this. I am just drawing the diagram. Many people don't know how to draw the diagram. Here you have taken a element, current is flowing in this direction, this angle is 90 degree. So you have to apply Biot-Savart's law, dB equals to mu naught by 4 pi I dl. Sin theta is 90 degrees, so there will be no sin theta here, dl by this distance. Okay, this is say r, dl by r square. Okay, now radius of the circular loop is r, and distance from the point is, from the center is x. Okay, and this will be the direction of dB. Okay, if this angle is theta, this angle is say phi, because theta we use for angle for Biot-Savart's law, so we are using phi here, then this angle will also be phi. Okay, now for this point you will get a dB here. Okay, so you can take two components, one component is along y-axis, one component along x-axis. Okay, but interestingly what will happen is, if you take diametrically opposite point here, then you will find a dB along this direction and it will have a component here. Okay, so the y components will cancel each other, but x components, it will also have some angle phi, so x component they will be adding up. So y components will cancel each other, but x components will remain. So only thing that you have to calculate is the x component. So dBx equals to mu naught by 4 pi, and what is the x component? This angle is phi, so x component will be dB cos phi. So adjacent is cos, perpendicular is sine, so I dl by r square cos phi, yes. Now what is cos phi? To find cos phi you have to use this triangle. Okay, cos phi is base by hypotenuse. Cos is base by hypotenuse. So if this is the angle, then base is this adjacent side and hypotenuse is obviously this. Okay, so base by hypotenuse. Now what is hypotenuse? Hypotenuse here is, if you apply Pythagoras theorem, then this will be equals to square root of r square plus x square. Okay, so you have to put this value. Okay, now insert all the values here. So mu naught by 4 pi, okay, I dl, r square is square of this thing, so it will be r square plus x square, and dl is dl, cos theta is r by square root of r square plus x square. So let me write it like this, square root can be written by to the power half. Now to find the total magnetic field, you have to do the integration of this component. Now if you see, everything is constant except this dl term. So what is this dl? dl is the small portion of this circular loop. So you take all the circular portions, if you add them, then you will get the total length. Total length is nothing but the circumference of the circle. What is the formula for circumference of the circle? 2 pi r, right? 2 pi r, nothing complicated. So mu naught by 4 pi, okay, I r dl integration is 2 pi r divided by r square plus x square. See, here it is 1, here it is half, so 1 plus half, that is equals to 3 by 2. Okay, now here 2 pi, 4 pi will cancel, only 2 will be left, and then we can write mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. Very important derivation, that's why I am done it. While doing the class, regular class, I have not done this derivation, so I done that derivation as well. Okay, I hopeful that it will help you. Now I am giving you two numerical questions. as a bonus, you can try and solve them. The problems are already solved during my class. These are only sample questions. There can be 100 different types of problems. So if you are not practicing, then you can at least practice problems from these two chapters that I recommend. First chapter is electric charges and field chapter, okay, and this type of question came in your last year board exam, so you can practice this type of question. This is one of the common question, but this is not the only one. There are 3-4 different variations of the question, so you can practice one such question. And the answer of this question is given 3600 Newton per Coulomb and 0. Pause the video, read the question, try to solve it, okay. Otherwise you can check electric charges and field video, electrostatic video that I have done in the first video, okay. There we have solved this question. And next is this video, this problem, okay. This is from AC chapter. Also in AC chapter there are 4 different variation of questions possible, okay, only 4 variations. Out of those 4 variation, one question is guaranteed to come in your exam, okay. Either maybe they may skip it in your midterm questions, but it will definitely come in your final exam. So this is one of the type question that I think might be important for your midterm. That's why I have added it, and the answer for this is given here, 5 ohm and 40 ampere. Pause the video, read the question, try to answer them, okay. And if you face any difficulty, you can mention that. Actual solution is already done in our AC chapter, okay, AC chapter video, okay. In future, after your midterm is over, before your annual exam, definitely I am going to do numerical series for your final exam. So till then I will be back with more such videos. Also, if you are not following our KSET series, there we are discussing all the important topics, all the important concepts for KSET. Do follow that playlist, and I will be back with more such videos in future. Till then, tata, bye bye.